The signals are cut, the noise has faded. Welcome back to the Silence of the Black series. Today we walk together once more in the deepest corners of the universe, chasing the unknown. A new secret in every video, a moment of peace in every second. Don't forget to subscribe to stay with me on this journey. Take a deep breath. We are beginning. You stand at the edge of creation, watching as the earth itself prepares to scream. Beneath your feet, invisible but unmistakable, a pressure is building that defies comprehension. Deep underground, in chambers that have been silent for centuries, molten rock is stirring, rising, demanding release. The ground trembles slightly, a warning, a prelude to what is coming. The mountain before you is not like other mountains. Its slopes are steep, its summit crowned with a crater that exhales thin wisps of steam. For years it has slept, but now it is waking. The tremors grow stronger, more frequent. The steam thickens, darkens, carries the smell of sulfur. You feel it before you see it, a deep, rumbling vibration that travels through the earth and up through your body. It is the sound of rock fracturing under immense pressure, of magma forcing its way through cracks and fissures, of the planet itself straining to contain forces that cannot be contained. And then, with a roar that shakes the very foundations of the world, the mountain erupts. A column of ash and gas explodes from the summit, rising with terrifying speed. It is not gray or white, this column. It is black, impossibly black, a pillar of darkness that climbs toward the sky like a living thing. It rises higher and higher, punching through clouds, reaching toward the stratosphere, spreading out at its top into a vast umbrella of ash. The sky darkens. The sun, which moments ago was bright and warm, dims to a pale disk, then vanishes entirely. The world is plunged into a twilight that is neither day nor night, a gray darkness lit only by the red glow of the erupting mountain. You watch as the ash column continues to rise, now tens of thousands of feet high, its top spreading like a mushroom cloud. Within it, you can see the violence. Rocks the size of cars are hurled skyward, glowing red with heat. Fragments of the mountain itself are torn apart and scattered. Gases that have been trapped for millennia are released in an instant. The sound is overwhelming, a continuous roar that is felt as much as heard, that vibrates in your chest, in your bones, in your very soul. It is the sound of the earth's fury, of pressure finally released, of energy that has been building for centuries pouring out in moments. You think about what is happening beneath you, in the hidden chambers where this fury began. Deep underground, magma has been accumulating, heated by the planet's core, pressurized by the weight of overlying rock. The pressure built slowly at first, then faster as more magma rose from below. The chamber swelled, stretched the surrounding rock, created cracks and fissures. And then, when the pressure became too great, the rock gave way. The magma found a path to the surface, rushing upward with unimaginable force. As it rose, the pressure decreased, and gases that were dissolved in the magma began to come out of solution, expanding violently, adding to the explosive force. This is the moment when rock becomes plasma. The intense heat and pressure strip electrons from atoms, creating a fourth state of matter that exists only in the most extreme conditions. Deep in the throat of the volcano, rock is not just melted, it is ionized, transformed into a glowing, electrically conductive fluid. You watch as the column continues to rise, now so high that its top is lost in the darkness. The ash spreads, covering the land for hundreds of miles, blocking the sun, turning day into night. Animals flee, birds fall from the sky, the world becomes a scene of biblical destruction. But in the midst of this chaos, there is a strange beauty. The column glows from within, lit by the heat of the magma, by the flashes of internal lightning that are just beginning to form. Pulses breathes lives. It is a creature of fire and ash, born from the earth's fury. You stand there, rooted to the spot, unable to look away. The power on display is humbling, terrifying, awe-inspiring. This is creation and destruction in the same moment, the same force that built the mountains now tearing one apart. The ash begins to fall around you, fine particles that settle on your shoulders, your hair, your skin. It is soft, almost like snow, but it carries the weight of the mountain, the memory of the explosion. Each flake is a piece of the volcano, a fragment of the Earth's interior, brought to the surface in this violent release. You raise your hand and let the ash fall on your palm. It is warm, still carrying the heat of its origin. You close your fingers around it, feeling its texture, its presence. This ash was rock deep underground just hours ago. Now it is here in your hand, a messenger from the depths. The eruption continues, hours passing like minutes. The column rises and falls, pulses with energy, reshapes itself constantly. The sound never stops, a continuous roar that has become the background of existence. The world has been reduced to this: the mountain, the ash, the darkness, and you. You think about the forces at work here. The pressure that drove this eruption is measured in tons per square inch, enough to crush anything in its path. The temperature of the magma is over 1,000 degrees Celsius, hot enough to melt rock, to vaporize water, to transform matter itself. And yet, standing here, you feel a strange peace. The violence is overwhelming, but it is also natural, necessary, part of the cycle of the planet. The mountain is not angry, it is simply releasing pressure that has built over centuries. The eruption is not destruction, it is creation, building new land, new rock, new possibilities. The ash continues to fall, building a soft gray blanket over the landscape. The world is being buried, transformed, made new. When the eruption ends, this ash will become soil, rich with minerals from the Earth's interior, fertile ground for new life. You stand there, covered in ash, watching the mountain rage. The darkness is complete now, the sun entirely blocked by the towering column. The only light comes from the volcano itself, from the glow of magma at its summit, from the flashes of lightning that are beginning to flicker within the ash cloud. The first lightning bolt appears, a brief flash of light that illuminates the column from within. It is not the familiar white of a thunderstorm, but something else. tinged with purple, with violet, with colors you have no name for. It is dirty lightning, born not from ice crystals but from ash particles, from the friction of rock against rock. You watch as more bolts appear, flickering within the column like a living nervous system. The ash cloud has become a battery, storing immense electrical charge, releasing it in these spectacular discharges. The mountain is not just erupting, it is generating its own weather, its own lightning, its own light. The flashes illuminate your face, casting strange shadows, revealing the ash that covers you. You are becoming part of this landscape, part of the eruption, part of the story. The mountain's fury is now your experience, its violence now your memory. You think about what comes next. The eruption will continue, perhaps for hours, perhaps for days. The lightning will intensify, then fade. The ash will continue to fall, building its gray blanket. And eventually the mountain will quiet, the pressure will be released, the eruption will end. But for now there is only this moment. The roar, the darkness, the ash, and the flashes of purple light. This is the fury beneath the earth, made visible, made manifest, made real. You close your eyes and feel it all, the vibration in the ground, the sound in your bones, the ash on your skin. You are present at one of the planet's most powerful displays, a witness to the force that shapes worlds. When you open your eyes, the mountain is still erupting, the lightning still flashing, the ash still falling. The moment continues as it will for hours yet. But you have seen what you came to see, felt what you came to feel. The fury beneath the earth has spoken, and you have listened. You stand beneath the towering column of ash, watching as the eruption continues its relentless fury. But now your perspective shifts, zooms in, descends into the microscopic world where a different kind of violence is unfolding. Within the vast cloud of ash that darkens the sky, trillions upon trillions of particles are engaged in a conflict you cannot see but whose effects are becoming impossible to ignore. The ash cloud is not a uniform mass. It is a chaotic storm of particles, each one with its own story, its own journey, its own destiny. Some are large, the size of sand grains, heavy enough to fall back to earth within minutes. Others are microscopic, finer than flour, light enough to remain suspended for days, weeks, even years. They come from deep within the earth, from rock that was once part of the planet's crust, from magma that has not seen the surface in millions of years. As they rise and fall, swirl and collide, these particles engage in a constant dance of friction. They rub against each other, scrape past each other, crash into each other with forces that are tiny individually but immense collectively. And with each collision, something happens. Electrons are transferred. Charges build. The cloud becomes electrified. You imagine yourself shrinking, becoming small enough to ride among these particles, to witness the microscopic conflict firsthand. The world around you transforms. The towering column becomes a vast, churning universe of particles, each one a world unto itself. They tumble and spin, their surfaces rough with crystalline structures, their edges sharp from fracture. Some glow with residual heat, still warm from their journey through the volcano's throat. Others have cooled, become dark, become just another fragment in the endless swarm. A particle approaches you, a tiny shard of volcanic glass no larger than a bacterium. Its surface is smooth in some places, jagged in others, marked by the violence of its creation. As it tumbles past, it brushes against another particle, a crystalline fragment of feldspar. For an instant they touch, their surfaces grinding together with microscopic force. In that instant, an electron leaps from one to the other, a tiny transfer of charge that is happening billions of times per second throughout the cloud. This is the beginning. This is how a volcanic ash cloud becomes a battery. The physics is simple in principle, complex in practice. When two dissimilar materials rub together, electrons can transfer from one to the other. This is triboelectric charging, the same phenomenon that makes a balloon stick to a wall after you rub it on your hair. In the ash cloud, it happens on an unimaginable scale, with trillions of particles colliding trillions of times per second. But the ash cloud is not made of just two materials. It contains countless different substances: volcanic glass, feldspar, pyroxene, olivine, fragments of older rock torn from the volcano's conduit, crystals that formed in the magma chamber over centuries. Each material has its own tendency to gain or lose electrons, its own place in the triboelectric series. The collisions are constant, the charge transfer relentless. You watch as the particles sort themselves by charge. Some become positively charged, having lost electrons. Others become negatively charged, having gained them. They begin to separate, driven by the turbulent motions of the cloud, by differences in size and weight, by the very forces of the eruption itself. The positive charges accumulate in one region, the negative in another. A voltage builds, small at first, then larger, then immense. The cloud is becoming a capacitor, storing electrical energy on a scale that dwarfs anything humans can create. The voltage rises, reaches millions, then tens of millions, then hundreds of millions of volts. The electric field becomes so intense that the very air begins to ionize, molecules stripped of their electrons, turned into conductive paths. You float among the particles, feeling the growing tension. The air itself feels different, charged, alive. Your hair stands on end if you had hair. Tiny sparks leap between nearby particles, miniature lightning bolts that flicker and die in microseconds. The cloud is preparing to discharge, to release the energy it has been storing through countless microscopic collisions. And then it happens. A path of ionized air forms, connecting a region of positive charge to a region of negative charge. For an instant, the resistance vanishes. The stored energy releases in a catastrophic rush. A bolt of lightning tears through the cloud, so bright that it seems to outshine the sun, though the sun is hidden behind the ash. The bolt is not white, not the familiar color of thunderstorm lightning. It is purple, shot through with violet and magenta, colors that seem to come from another world. This is dirty lightning, born not from ice crystals but from rock and ash, carrying the signature of its volcanic origin. You watch as the bolt illuminates the cloud from within, revealing its structure in an instant of brilliance. You see the churning columns of ash, the swirling eddies, the dense regions where particles cluster. You see the path the lightning took, a branching tree of light that forks and rejoins, in patterns that seem almost organic. The thunder follows, a sound so deep and powerful that it shakes you to your core. It is not the sharp crack of a nearby lightning strike, but a rolling, rumbling, continuous roar that goes on, echoing off the cloud boundaries, reverberating through the ash-filled air. It is the sound of immense energy released, of forces that have been building for hours finally finding expression. More bolts follow. The cloud has become a lightning factory, generating discharge after discharge as the particles continue their endless collisions. Each bolt is different, some branching wide, some narrow and intense, some so bright they leave after images burned into your vision. The colors vary too, from deep violet to pink to almost white, depending on the composition of the ash, the temperature of the discharge, the path the lightning takes. You think about what is happening at the molecular level during these discharges. The lightning bolt is not just light and sound, it is a chemical factory. The intense heat and pressure create compounds that do not exist under normal conditions. Nitrogen and oxygen combine to form nitrogen oxides. Water vapor breaks apart and recombines in new ways. Even the ash particles themselves are transformed, their surfaces melted and reshaped by the brief but intense heat. These chemical reactions have consequences. The nitrogen oxides produced by volcanic lightning contribute to the formation of ozone, affecting atmospheric chemistry on a global scale. The compounds created in the discharge may have played a role in the origin of life, providing the building blocks for the first organic molecules. The lightning that seems so destructive may also be creative, generating the chemical precursors of life itself. You float there, surrounded by this electrical storm, watching as bolt after bolt illuminates the cloud. The particles continue their endless dance, colliding, transferring charge, building new voltages to replace those just discharged. The process is self-sustaining, a feedback loop that will continue as long as the eruption lasts. The microscopic conflict that began with a single particle brushing against another has escalated into a full-scale electrical war. The cloud has become a battlefield where the weapons are electrons and the casualties are measured in volts. And at the center of it all, you witness, you observe, you remember. A bolt strikes nearby, so close that you feel the heat, hear the crack, smell the ozone. The light illuminates your face, casting strange shadows, revealing the awe in your expression. You are witnessing something that few humans have ever seen, something that speaks to the power and complexity of nature. The particles continue their dance. The lightning continues its displays. The microscopic conflict continues, unseen from the ground but essential to the spectacle above. And you remain a witness to it all, a consciousness present at one of nature's most magnificent shows. This is the microscopic conflict. This is the friction that creates lightning. This is the hidden war that turns a volcanic ash cloud into an electrical storm. You float within the electrified cloud, surrounded by the chaos of trillions of colliding particles. The air itself crackles with energy, each molecule seemingly alive with the tension that precedes discharge. And then, in a moment that seems to freeze time, the first purple bolt tears through the darkness. It is not like any lightning you have ever seen. The familiar lightning of a summer thunderstorm is white, sometimes tinged with blue, bright and sharp and clean. This is different. This lightning is purple, deep violet, shot through with magenta and hints of crimson. It is dirty lightning, born not from the pristine ice crystals of high thunderclouds but from the gritty, grinding chaos of volcanic ash. The bolt illuminates everything in an instant. You see the internal structure of the cloud as if it were laid bare. The dense columns of ash rising from the vent, the turbulent eddies where particles of different sizes separate, the regions where charge has accumulated to critical levels. And then the light fades and you are in darkness again, waiting for the next bolt. It comes quickly, another purple lance stabbing through the cloud. This one is different from the first, broader, more diffuse, its color shifting from violet at the core to pink at the edges. It branches and forks, creating a tree of light that exists for only a fraction of a second but leaves its image burned into your vision. You watch as more bolts follow, each one unique, each one beautiful in its own terrible way. Some are narrow and intense, like purple needles threading through the cloud. Others are broad and diffuse, lighting up vast regions at once. Some are nearly white at their core with only a hint of violet at the edges. Others are so deeply purple that they seem almost black, their light barely visible against the darkness of the ash. The science behind these colors is as fascinating as the spectacle itself. The color of lightning is determined by what it passes through, by the gases and particles that absorb and emit light along its path. In a normal thunderstorm, lightning passes through clean air, rich in nitrogen and oxygen. The light emitted is dominated by the spectral lines of these gases, producing the familiar white-blue glow. But volcanic lightning passes through air that is anything but clean. The ash cloud is filled with particles of rock and glass, with gases like sulfur dioxide and hydrogen sulfide, with droplets of sulfuric acid. Each of these interacts with the light from the lightning bolt, absorbing some wavelengths, emitting others, creating a spectrum that is uniquely volcanic. The purple color comes primarily from the way light scatters off the ash particles. The fine particles preferentially scatter shorter wavelengths, the blues and violets, while allowing longer wavelengths to pass through. The lightning bolt's light, already rich in these colors, is further enriched by scattering, creating the characteristic purple hue. But there is more to it than simple scattering. The electrical discharge itself is different in the volcanic environment. The high concentration of particles creates a dirty discharge, one that follows different paths, creates different temperatures, produces different excited states. The plasma that forms the lightning channel is not pure air but a mixture of air, vaporized rock, and ionized gases. Its emission spectrum is correspondingly complex. You watch as a particularly bright bolt illuminates the cloud, revealing details you had not seen before. The ash particles themselves seem to glow briefly, each one catching the light and throwing it back in a million directions. For an instant, the entire cloud sparkles with tiny points of reflected light, like a billion diamonds scattered across the sky. Then darkness returns, deeper than before, and you wait for the next bolt. The frequency of the lightning is increasing now, as the eruption intensifies and the cloud becomes more charged. Bolts come every few seconds, sometimes overlapping, creating a continuous flicker of purple light. The cloud has become a strobe light, illuminating the landscape below in a series of frozen moments. You look down through the cloud, catching glimpses of the ground in the flashes. The volcano slopes are visible, covered with fresh ash, glowing in places with the heat of new lava. Rivers of molten rock creep down the mountainside, their progress visible in the intermittent light. The landscape looks alien, transformed like the surface of another world. The lightning is not confined to the cloud itself. Some bolts strike the ground, connecting the charged cloud to the earth below. These ground strikes are particularly spectacular, their purple light illuminating the landscape for miles around. You watch as one such bolt strikes the volcano's flank, the impact sending up a shower of rock and ash, adding to the chaos of the eruption. The sound of these ground strikes is different too. The thunder is deeper, more resonant, carrying through the ash-choked air with a quality that is almost musical. It rumbles and rolls, echoing off the mountain slopes, reverberating through the cloud, creating a continuous backdrop of sound that underlies everything. You think about what it would be like to be on the ground during this display. To stand on the ash-covered slopes, watching these purple bolts rain down from the sky. The danger would be immense, the risk of being struck real. But the spectacle would be unforgettable, a light show unlike anything else on Earth. The lightning continues, hour after hour, as the eruption shows no sign of weakening. The cloud has become a self-sustaining electrical machine, its particles constantly colliding, constantly charging, constantly discharging. The energy being released is staggering, equivalent to multiple nuclear explosions per minute, all in the form of purple light and thunderous sound. You float within this maelstrom, protected by your observer's immunity, watching as nature puts on one of its most spectacular shows. The purple bolts illuminate your face, casting strange shadows, revealing the awe in your expression. You are witnessing something that few humans have ever seen, something that speaks to the raw power of the planet. A particularly massive bolt forms nearby, its channel widening as it grows. You watch as it takes shape, a tree of light that seems to grow in slow motion, its branches reaching out in all directions. The color shifts as it develops, starting as a deep violet at the base, becoming pinker toward the tips, ending in near white at the finest branches. The thunder that follows is deafening, a continuous roar that goes on for tens of seconds. It shakes the cloud, shakes you, shakes everything. The sound waves themselves interact with the ash, creating patterns of compression and rarefaction that affect the lightning's behavior. The whole system is coupled, acoustics and electricity and particle dynamics all intertwined. You realize that you are witnessing something more than just lightning. You are witnessing a complex system, a network of feedback loops and interactions that create order out of chaos. The lightning is not random, it is structured, patterned, organized by the very forces that create it. The purple color is not accidental. It is the signature of a unique environment, a fingerprint of the volcanic process. The bolts continue, each one adding to the spectacle. The cloud flickers continuously now, the individual bolts merging into a general glow. It is as if the entire cloud has become a light source, pulsing with purple energy. The effect is mesmerizing, hypnotic, beautiful. You think about the role this lightning plays in the larger Earth system. Volcanic lightning is rare, confined to the most powerful eruptions. But when it occurs, it has global effects. The nitrogen oxides produced by the discharges affect atmospheric chemistry. The compounds created may seed clouds, affect weather patterns, influence climate. The purple light itself, scattered by the atmosphere, can be seen for hundreds of miles. But for now, you set aside these larger thoughts and simply watch. The beauty of the moment is enough, the spectacle sufficient. You are present at the birth of purple, at the creation of dirty lightning, at a moment when nature reveals one of its most secret faces. A final massive bolt tears through the cloud, the largest yet, illuminating everything for miles around. In its light, you see the full extent of the eruption. The towering column, the spreading ash cloud, the lava flows, the transformed landscape. It is a vision of creation and destruction combined, of power beyond comprehension, of beauty beyond description. The light fades and darkness returns. But the image remains, burned into your memory, a permanent record of this moment. The lightning continues, but you have seen enough. You understand now what dirty thunderstorms are, how they form, why they are purple. You have witnessed the birth of this strange and beautiful phenomenon. You are ready to move on, to explore the next aspect of this volcanic spectacle. But you will carry the memory of the purple lightning with you forever. You float within the heart of the volcanic storm, surrounded by the continuous flicker of purple lightning. The ash cloud has become something more than a simple eruption product. It is a living, breathing entity generating its own weather, its own electricity, its own light. And at the center of it all, driving everything, is heat. The heat that fuels this spectacle comes from deep within the earth, from magma that has traveled miles through the crust to reach the surface. Its temperature is staggering, over 1,000 degrees Celsius, hot enough to melt rock, to vaporize water, to transform the very nature of matter. This heat rises with the ash column, carried upward by the explosive force of the eruption, creating a thermal plume that reaches into the stratosphere. You feel this heat even through your protected observer's perspective. It radiates from the column, a constant, oppressive warmth that would be unbearable in any other context. But here, in the midst of the eruption, It is simply part of the environment, as natural as the ash and the lightning. The thermal dynamics of the plume are incredibly complex. Hot gas and ash rise from the vent at supersonic speeds, creating a turbulent column that can reach heights of 30 miles or more. As it rises, it entrains surrounding air, mixing and cooling, but the core remains intensely hot. The temperature differences between the core and the edges, between the rising column and the surrounding atmosphere, create powerful convection currents that shape the cloud's behavior. You watch as these currents manifest in the lightning patterns. The bolts are not random. They follow the thermal structure of the cloud, clustering in regions where temperature gradients are steepest, where the mixing of hot and cold air is most intense. The lightning becomes a map of the cloud's internal dynamics, a visible expression of invisible thermal forces. A particularly bright bolt illuminates a region where a pocket of exceptionally hot gas has risen rapidly through cooler ash. The temperature difference is hundreds of degrees, creating a sharp boundary that concentrates electrical charge. The bolt traces this boundary perfectly, its purple light revealing the shape of the thermal anomaly. You realize that you are watching a system of remarkable complexity. The heat from the magma drives the eruption, which creates the ash cloud, which generates the lightning, which in turn affects the cloud's chemistry and dynamics. Everything is connected, everything is in balance, everything is part of an intricate dance of energy and matter. The concept of an electric cauldron comes to mind. The volcanic plume is exactly that, a cauldron where thermal energy is converted into electrical energy, where heat becomes light, where chaos gives birth to order. The processes at work are not random. They are governed by physical laws that operate on scales from the microscopic to the global. You think about the energy budget of this system. The heat released by the eruption is measured in gigawatts, enough to power entire cities. A fraction of that heat is converted into electrical energy, stored in the cloud as static charge, released as lightning. The efficiency of this conversion is low, but the absolute amount of energy is so vast that the lightning produced is still spectacular. A series of bolts flashes in quick succession, creating a strobe effect that illuminates the entire cloud. In the flickering light, you see the full complexity of the thermal structure. Rising plumes of hot gas, descending curtains of cooler ash, swirling eddies where temperatures mix, sharp boundaries where temperature gradients are steep. The cloud is alive with motion, a living thing driven by heat. The sound of the lightning merges with the continuous roar of the eruption, creating a symphony of noise that is both overwhelming and strangely musical. The deep rumble of the volcano, the sharp cracks of nearby lightning, the rolling thunder of distant discharges, all combine into a single complex auditory experience that defies description. You close your eyes and simply listen, letting the sound wash over you. The rhythm is there, underneath everything, a pulse, a beat, a pattern that emerges from the chaos. The lightning strikes at intervals that are not random, clustered around a characteristic frequency determined by the cloud's charging rate. The thunder follows, its timing shaped by the distance and the acoustic properties of the ash-filled air. The eruption itself provides a constant bass note, a drone that underlies everything. This is the rhythm of thermal chaos. This is the music of the electric cauldron. You open your eyes and watch as another series of bolts illuminates the cloud. The pattern is clearer now once you know what to look for. The lightning concentrates where the thermal gradients are steepest, where hot and cold air mix most intensely. It follows the boundaries between different temperature regimes, tracing them like a living map. The implications of this are profound. The lightning is not just a byproduct of the eruption. It is an integral part of the system, a component that feeds back into the dynamics. The electrical discharges heat the air, creating new temperature gradients. They ionize gases, changing their chemical properties. They affect the behavior of ash particles, influencing how they aggregate and fall. The cloud is a system of incredible complexity, with feedback loops operating on multiple scales. The heat drives the convection, which drives the charging, which drives the lightning, which affects the heat distribution. Everything is connected, everything is in balance, everything is part of an intricate whole. You think about how such systems evolve over time. The eruption is not static. It pulses, fluctuates, changes. The rate of magma rise varies, the gas content fluctuates, the vent geometry changes. Each of these variations affects the thermal dynamics, which affects the lightning, which affects everything else. The cloud is a living thing, constantly adapting, constantly changing. A particularly powerful pulse of magma rises from below, increasing the eruption intensity. The column surges upward, growing taller and wider. The additional heat creates new thermal gradients, new regions of intense mixing. The lightning responds almost instantly, with a flurry of bolts that illuminate the expanding cloud. You watch as the system finds a new equilibrium. The lightning rate increases, then stabilizes at a higher level. The pattern of discharges shifts, concentrating around the new thermal structures. The cloud adjusts, reorganizes, continues its complex dance. This is the beauty of such systems. They are never truly stable, never truly static. They exist in a state of dynamic equilibrium, constantly adjusting to changing conditions, constantly finding new balances. The lightning is not just a phenomenon. It is a symptom of this constant adjustment, a visible expression of the system's attempt to maintain itself. The hours pass, though time has little meaning here. The eruption continues, the lightning continues, the dance continues. You float within the cloud, observing, learning, understanding. The complexity is overwhelming, but patterns emerge. You notice that the lightning tends to cluster in certain regions of the cloud, near the edges where the column interacts with the surrounding atmosphere, in the upper reaches where the ash spreads out into an umbrella, along the boundaries between different temperature regimes. These are the regions of maximum thermal contrast, where the driving forces are strongest. You also notice that the lightning has a characteristic frequency, a rhythm that emerges from the chaos. The intervals between discharges are not random. They cluster around a mean value that is determined by the cloud's charging rate. The system has a natural frequency, a pulse, a heartbeat. This heartbeat is the rhythm of thermal chaos, the pulse of the electric cauldron. It is the sound of heat becoming light, of energy transforming, of the planet's inner fire reaching toward the sky. You think about what this means for understanding volcanic systems. The lightning is not just a spectacular sideshow. It is a diagnostic tool, a way of probing the internal dynamics of the eruption. The frequency and distribution of discharges reveal information about the thermal structure, the ash concentration, the gas content. By studying the lightning, scientists can learn about processes that are otherwise invisible. A massive bolt strikes nearby, so close that you feel the heat and hear the crack before the thunder. It illuminates everything, revealing details you had not noticed before. Fine structures in the ash, delicate patterns of charge distribution, subtle variations in particle concentration. For an instant, the cloud is transparent, its secrets laid bare. Then darkness returns and you are left with the afterimage burned into your memory. You realize that you have been here for hours, perhaps days. The eruption shows no sign of weakening, the lightning no sign of stopping. The system has achieved a kind of steady state, a dynamic equilibrium that could persist for as long as the magma continues to rise. You think about the larger context. This eruption is just one of thousands happening around the world, on land and under the sea. Each one generates its own electric cauldron, its own thermal chaos, its own rhythm of lightning. Collectively, they contribute to the global electrical circuit, affecting weather and climate in ways that are only beginning to be understood. The lightning flashes, illuminating your face one last time before you decide to move on. You have seen enough, learned enough, understood enough. The rhythm of thermal chaos is now part of your experience, the electric cauldron now part of your memory. You begin to drift away from the cloud, descending toward the ground below. The lightning continues above you, its purple light fading as you descend. The roar of the eruption becomes more distant, replaced by the softer sounds of falling ash. You look back one last time at the towering column lit from within by countless flashes. It is beautiful, terrible, awe-inspiring. It is nature at its most powerful, its most creative, its most destructive. And you were there. You witnessed the rhythm of thermal chaos. You felt the pulse of the electric cauldron. You will carry it with you forever. You stand on the ash-covered ground, watching as the eruption that has consumed your attention for so long finally begins to weaken. The transformation is so gradual that you almost miss it. A slight decrease in the roar, a subtle thinning of the ash column, a longer pause between lightning strikes. But once you notice, you cannot unsee it. The mountain is winding down, its fury finally subsiding after days of relentless violence. The towering column of ash that has darkened the sky since the eruption began is no longer the monolithic structure it once was. Its top, which reached 30 miles into the stratosphere at the peak of activity, has dropped by half. The umbrella cloud that spread for hundreds of miles, blocking the sun and turning day into night, is contracting, pulling back toward the vent like a dying star collapsing under its own weight. You watch as the purple lightning within the cloud grows weaker, less frequent. Where once bolts flashed every few seconds, now minutes pass between discharges. The color has shifted too, from deep violet to pale pink, as if the electricity itself is fading, losing its intensity. A single bolt flickers near the top of the column, weak and diffuse, its light barely penetrating the ash. It is a final gasp, a last expression of the electrical energy that has been so abundant. Then it fades and the cloud goes dark. The silence that follows is more profound than anything you have ever experienced. After days of continuous roar, of constant thunder, of the earth's endless shouting, the quiet is overwhelming. It presses against your ears, fills your consciousness, becomes a presence in itself. You stand perfectly still, barely breathing, waiting for the sound to return. But it does not. The eruption is over. The ash begins to fall. It starts as a light dusting, barely noticeable, a few gray flakes drifting down from the dark sky like the first snow of winter. You watch them descend, their paths erratic, caught by whatever gentle air currents remain. They land on your outstretched hand, tiny fragments of volcanic glass, still warm from their journey through the Earth's interior. Within minutes, the light dusting becomes a steady rain. The flakes fall faster now, thicker, closer together. They accumulate on the ground, on the rocks, on every surface. The landscape begins to transform before your eyes, the familiar contours of the land disappearing under a growing blanket of gray. Soon the steady rain becomes a downpour. Ash falls so thickly that you can barely see more than a few feet in any direction. It piles up against obstacles, creating drifts that grow by the minute. The weight of it bends branches, collapses weaker structures, buries everything in its path. And then the downpour becomes a blizzard. Ash falls so heavily that it is less like rain and more like being inside a snow globe that someone is constantly shaking. You cannot see the mountain anymore, cannot see the sky, can barely see your own hand in front of your face. The world has been reduced to a swirling chaos of gray. You stand in the midst of this falling ash, letting it accumulate on your shoulders, your head, your outstretched arms. It is warm at first, still carrying the heat of its origin deep within the earth. But it cools quickly as it falls, becoming neutral, then cold against your skin. The flakes are soft, almost fluffy like the finest powder, but they have weight, substance, presence. Each one is a tiny piece of the mountain, a fragment of the Earth's interior brought to the surface in an instant of violence and now returning to the ground in a moment of peace. You lift your hand and catch a single flake, examining it as closely as the limited visibility allows. It is a tiny shard of volcanic glass, no larger than a grain of sand, its edges sharp despite its size. Under a microscope, it would reveal gas bubbles frozen in place, crystal structures formed during its rapid cooling, the hung-ji of its violent journey through the volcano's throat. It is beautiful in its own way, this tiny fragment, a piece of the story made visible. The ash continues to fall hour after hour. Time loses meaning in the gray chaos. You have no way of knowing whether minutes or hours are passing. The accumulation is staggering, inches per hour, feet before long. The landscape is being buried, transformed, made new. The mountain itself has disappeared behind the falling curtain, its outline completely obscured. For all you know, it could be gone, erased from existence by its own eruption. You think about the scale of what is happening. The ash falling around you represents only a tiny fraction of what the eruption produced. Most of it has already settled elsewhere, carried by wind currents to distant lands. Some will circle the globe, affecting climate for years to come. Some will fall into the ocean, settling on the seafloor, becoming part of the geological record. Some will be inhaled by living things, causing respiratory problems for creatures hundreds of miles away. The reach of this eruption extends far beyond what you can see. But for now there is only this: the falling ash, the growing silence, the sense of an ending. You begin to walk through the accumulating ash, though walk is perhaps too strong a word. Each step requires effort, lifting your foot high to clear the deepening layer, placing it down carefully to maintain balance. The ash is soft, unstable, giving way beneath you like the finest sand. Behind you, your footprints fill almost instantly, erased by the continuing fall. It is as if you were never there, as if no one had ever passed this way. The world has become a blank slate, a canvas of gray waiting for whatever comes next. All the details that once defined this landscape, the rocks, the plants, the subtle contours of the land, have been buried, hidden, smoothed over. What remains is a uniform surface, featureless and endless, stretching in all directions as far as the limited visibility allows. The only sound is the soft hiss of falling particles. It is so gentle that it barely registers as sound at all, more a presence than a noise, a continuous whisper that underlies everything. Combined with the profound silence that followed the eruption's end, it creates an acoustic environment unlike anything you have ever experienced. The world is both utterly silent and filled with sound. The darkness that has enveloped the land since the eruption began is starting to lift. The change is imperceptible at first, but gradually you realize that the world is becoming brighter. The ash cloud is thinning, allowing more light to penetrate. The light that reaches you is diffuse, scattered, without shadows. The kind of light that exists on overcast days, when the sun is a bright spot behind clouds but casts no shadows. But it is light, and it is welcome after the oppressive darkness. You look up and see the sky for the first time in what feels like forever. It is still gray, still thick with suspended ash, but there are patches of blue, glimpses of the sun, hints of the world beyond the eruption's reach. The sight fills you with something you had forgotten you could feel: hope. The ash cloud is dissipating. The particles that have remained suspended for so long are finally settling, pulled by gravity back to Earth. Some will remain aloft for weeks, carried by high-altitude winds to distant continents. But most are falling now, joining the blanket that already covers the landscape. You stand in the thinning ash, watching as the world slowly reappears. The mountain emerges first, a dark shape against the gray sky. Its summit is still obscured by steam and residual ash, but its bulk is visible, solid and real. It has survived its own fury, though it is changed. The crater is wider now, the slopes reshaped by the eruption. The mountain will never be the same. As the ash continues to fall, more details emerge. The immediate landscape takes shape. The ridge line to your left, the valley to your right, the distant hills that mark the horizon. All are covered in gray, transformed into something new, but recognizable nonetheless. The ash fall is slowing now, the thick blizzard reduced to a gentle rain, then to scattered flakes, then to nothing. The last few particles drift down, catching the light, sparkling briefly before they land. And then, finally, the sky is clear. You stand in a world transformed. The gray blanket that covers everything is several feet deep, smooth and uniform, hiding the contours of the land beneath. It is beautiful in its simplicity, in its stillness, in its peace. The violence that created it has passed, and what remains is this: a quiet landscape, resting, recovering, waiting. You take a step and sink into the ash up to your knee. It is deeper than you thought, softer than you expected. Each step requires effort, but there is something meditative about the movement, something peaceful about the silence that surrounds you. You walk away from the mountain, leaving a trail of deep footprints behind you. They will not last long. Wind and rain will erase them, or more ash will cover them if the mountain stirs again. But for now, they mark your passage, proof that someone was here, that someone witnessed what happened. The ash beneath your feet is already beginning to change. In some places, it is being washed away by streams of water melting from the mountain slopes, carried into rivers that will eventually reach the sea. In others, it is being compacted by its own weight, beginning the long process of becoming rock. The cycle continues as it always does. You bend down and scoop up a handful of ash. It is warm, soft, almost silky in texture. It contains within it the entire story of the eruption, the magma from deep within the earth, the gases that drove the explosion, the lightning that illuminated the cloud, the violence that shaped the landscape. It is a piece of the mountain, a fragment of the event, a memory made solid. You let the ash run through your fingers, watching as it falls back to the ground, joining the rest of the gray blanket. The particles catch the light, sparkling briefly before they land. They are beautiful, these tiny fragments, in their own quiet way. The silence that surrounds you is absolute. No wind, no birds, no insects. The eruption has silenced everything, and nothing has yet returned. You are alone in a world of gray, the only living thing in a landscape that seems more like another planet than the Earth you know. You think about what you have witnessed. The eruption began with pressure building deep underground, forces so immense that they could not be contained. It continued with violence beyond imagination, ash and gas shooting miles into the sky, lightning flashing continuously within the cloud. It reached its peak with the thermal chaos of the electric cauldron, the mountain generating its own weather, its own electricity, its own light. And now it has ended with this: silence, ash, and the slow return of peace. The cycle is complete. The mountain has released its pressure, emptied its chambers, spent its fury. It will sleep now for decades or centuries or millennia, recovering, replenishing, preparing for the next eruption. And when it wakes again, the cycle will repeat. You think about the ash beneath your feet. In time, it will weather, break down, become soil. It will provide nutrients for new plants, support new life. The destruction wrought by the eruption will become the foundation for new growth, new ecosystems, new possibilities. The forest that once covered these slopes will return, different but alive. The animals that fled will return, finding new homes in the transformed landscape. This is the way of things. Destruction and creation are two sides of the same coin. The violence that devastates also enriches. The death that comes also brings life. The mountain takes, but it also gives. You walk on through the ash, away from the mountain. The gray blanket gradually thins as you move farther from the eruption's center. Here the ash is only inches deep, then only a dusting, then patches of bare ground appear. You are leaving the fall zone, entering the world that was spared the worst of the eruption. The transition is gradual but unmistakable. The ash-covered ground gives way to soil, then to grass, then to plants that somehow survived. Birds sing in the distance, the first sounds of life you have heard since the eruption began. The world is returning to normal, even as the mountain behind you remains transformed. You stop at the edge of the ash zone, 1 foot in the gray, 1 foot in the green. You are a creature of both now, carrying the memory of the eruption into the world beyond. The ash on your clothes, in your hair, on your skin is a reminder of where you have been, what you have seen. You look back at the mountain one last time. It stands silent in the distance, its slopes gray with ash, its summit still steaming faintly. It is beautiful in its own way, this mountain, even in its quiet, even in its rest. It has done what mountains do, and now it rests. The phrase, "the signals are cut," comes to you, and you understand its meaning. The eruption signals, the roar, the lightning, the ground tremors, have all ceased. The mountain is no longer communicating its fury. The signals are cut. What remains is silence. You turn away from the mountain, from the ash, from the transformed landscape. You step fully into the green world, leaving the gray behind. The grass is soft beneath your feet, the air is clean, the sun is warm. It is a different world, a world that did not experience the fury you have witnessed. But a part of you remains in the gray landscape. A part of you will always remain. The memory of what you have seen is now part of you, woven into your consciousness, as permanent as anything can be. You walk on, carrying that memory with you. The ash on your clothes will wash off, the ash in your hair will be brushed away, but the ash in your memory will remain. You will always be able to close your eyes and see the purple lightning, hear the roar of the eruption, feel the ash falling around you. The silent return of ash is complete. The eruption is over. The signals are cut. You walk into the green world, carrying the gray within you.